It was an unknown author who said, "In the old days, a man who saved money was a miser. Nowadays, he's a wonder." In this lesson, we're going to explain the concept of getting interest on your interest. And we're going to compute compound interest using a table. All to be able to answer the question, what is compound interest? To make sure we're ready for this lesson, let's start with warm-up number 2 and write an algebraic expression for the product of r and the square of 1 more than x. So important to get that 1 more than x part. That shows us that it is in a parentheses. And it says the square of, which means that it's squared. Now, product of means we're getting two things, r and that other thing, so r multiplying. Then we want to find the quotient of 1 more than x and the square of r. Saying quotient of means, of course, we have a division bar. 1 more than x means we have an x plus 1 in the numerator, and the square of r gets to go in the denominator. Now, let's take a look at a problem that you will be able to do by the end of this lesson. Jennifer has a bank account that compounds interest daily at a rate of 1.2%. On July 11th, the principal was $1,234.98. She withdrew $200 for car repair, and she deposited $34 from her check for her health insurance company. On July 12th, she had $345.77 as a paycheck directly deposited into her account. What is her balance at the end of July 12th? To start with, we need to figure out what her balance was when she started at $1,234.98. We can subtract the $200 and add the $34 to get $1,068.98. We're able to set up the C1 cell to be equal to a C4 times C2 times C3 divide 100. In the F2 cell, we then add the original balance and the interest earned. We have to add that 4 cents to the original balance so that we now have $1,069.02. Now, on the 12th, she deposited $345.77. This left her with $1,414.79. Entering that number into the new principal in the C7 cell, we can get our calculations. An interest of 5 cents was earned, and adding that to the prior balance, we get $1,414.84. When opening up a bank account, the annual interest rate is a major concern to most customers. However, it is not enough to just know the interest rate. How the interest rate is compound should also be known. Principal is used to compute interest. For simple interest, only the original principal is used to compute annual interest. The principal increase each time interest is added to the account. Sometimes interest is computed using a new principal. That is, the account earns interest on interest. Money earned on the money deposited plus previous interest is compound interest. This is not the case for simple interest. For simple interest, only the original principal is used to compute annual interest. Interest can be compounded in different ways. Annual compounding means interest is compounded once a year. Semi-annual means it is compounded twice a year or every 6 months. Quarterly compound means it's compounded 4 times a year or every 3 months, and daily compound means interest is compounded every day if there's 365 days in a year or 366 days in a year. The most common form of compounding is daily compounding. The bank pays interest every day based on the day's principal. They keep a record of interest earned and print it on your statement monthly or quarterly. This is commonly called crediting an account. Compounding daily and crediting monthly is the most common procedure used by banks today. Here we get to understand how compound interest works. This helps us to really see how interest accumulates. As we go through these examples, compare the results from each as it did the time before. So how much interest would $1,000 earn in 1 year at an annual rate of 2% compound annually? And what is the new balance? Well, by substituting in all of the values into our simple interest formula, we get $20 as the interest. Add to that the original balance of $1,000 and we get $1,020. Let's check our understanding and see how much would X dollars earn in 1 year at a rate of 4.4% compound annually. So we already know that simple interest is equal to PRT. Now, P is X. We don't know what that is. Our time frame is 1 year, and our interest rate is 4.4%. So we're going to wind up with 0.044 times X times 1. Now, the 1 multiplies and more or less disappears, leaving us with 0.44X. Now, let's explain the concept of getting interest on interest. Maria deposits $1,000 in a savings account that pays 2% interest compound semi-annually. What is her balance after 1 year? So the first thing we're going to have to do is compute the first 6 months. And we can do 1,000 times 0.02 times 0.5. The time of half a year is 0.5 years. Remember, time gets measured in years. This means the interest earned is $10. Add to that the $1,000 that was originally into the account, and we get $1,010. Now that was at the end of 6 months, but we have the other 6 months, which means we're going to multiply it by 0.02 times 0.05 again, and we get $10.10 interest on the $1,010. Add to that the $1,010 that she began that 6 months with, and we get $1,020.10. Let's check our understanding and look at Alex, who deposits $4,000 in a savings account that pays 5% interest compound semi-annually. What is the balance after 1 year? So we set up our simple interest formula with 4,000 as the P, 0.05 as the 5% interest, and 0.5 as 6 months for semi-annually. This means for interest earned, there will be $100. Adding to that the original $4,000 that was in the account, we get $4,100 at the end of 6 months. But times 5% times that next half a year, and another $102.50 is earned. We get to add that to the $4,100 that they began this cycle with, and we get $4,202.50. Well, how much interest does $1,000 earn in 3 months at an interest rate of 2% compound quarterly? And what is the balance after 3 months? When we set up our simple interest formula, the key here is they're saying 3 months. This is quarterly, and quarterly as a decimal is 0.25. This means the amount of interest earned is $5. Add to that the $1,000 that was originally in the account, and we get $1,005. Let's check our understanding and see how much $3,000 earns in 6 months at an interest rate of 4% compound quarterly. Remember, compound quarterly means that time frame is going to be equal to 1/4 or 0.25. So we set up our simple interest formula with the principal of $3,000 times the 4% interest times the quarter of a year. We see that there is $30 in interest earned. Add that to the $3,000 that the account started with, and we get $3,030. But we need to figure out the next quarter, so we multiply by the interest rate of 4% and by the quarter of the year, 0.25, and another $30.30 is earned, on top of the $30.30 that started this all, to have $3,060.30 at the end. So how much interest does $1,000 earn in 1 day at an interest rate of 2% compound daily? And what is the balance after that day? The key becomes compound daily. There is 1 out of 365 days that is going to become our T value. So I is equal to 1,000 times 0.02 times 1/365. Or you could look at it as simply divided by 365. And we see that 5 cents will be earned. Add that 5 cents to the 1,000, and we get $1,000.05. Let's check our understanding of this and see how much interest does X dollars earn in one day at an interest rate of 5% compound daily, and we're going to express this answer algebraically. So we set up our simple interest formula of I is equal to PRT, and we simply substitute in some values. Now, X is our P. We don't know that. The rate is 0.05, and we can divide this by 365, or the way I wrote it last time, we can multiply it by 1 over 365. Now, let's compute compound interest using a table. Jennifer has a bank account that compounds interest daily at a rate of 1.2%. On July 11th, the principal was $1,234.98. She withdrew $200 for car repair, and she deposited $34 from her check for her health insurance company. On July 12th, she had $345.77 as a paycheck directly deposited into her account. What is her balance at the end of July 12th? To start with, we need to figure out what her balance was when she started at $1,234.98. We can subtract the $200 and add the $34 to get $1,068.98. We're able to set up the C1 cell to be equal to a C4 times C2 times C3 divide 100. In the F2 cell, we then add the original balance and the interest earned. We have to add that 4 cents to the original balance so that we now have $1,069.02. Now, on the 12th, she deposited $345.77. This left her with $1,414.79. Entering that number into the new principal in the C7 cell, we can get our calculations. An interest of 5 cents was earned, and adding that to the prior balance, we get $1,414.84. Let's check our understanding of this. On January 7th, Jolie opened a savings account with $900. It earned 2.1% interest compound daily. On January 8th, she deposited her first paycheck of $76.22. What was her balance at the end of January 8th? Well, we start with $900 and we multiply that by 0.21, her interest rate. We can also divide it by 365 because we're multiplying by the time, which is 1 over 365. The interest earned will be 5 cents. Add to that the $900 she started with, and she has $900.05. But she then deposited her check of $76.22, giving her $976.27. Multiplying that by her interest rate of 2.1% and dividing it by 365 because it was daily means she earned 6 cents interest on that second day. Adding to that the $976.27 she started the day with, she gets to end with $976.33.